Well, so thank you very much for a nice introduction. What we already heard and we can see here, we will be talking about how learning and teaching mathematics can be related to personality of the student and possibly of the teacher too. But first let us introduce ourselves shortly. So here you can see the famous Professor Yuri Rogovchenko from our partner university, University of Agder, and me, myself, I'm
even more famous because he's my follower.
Coming from Brno University of Technology. Shortly about the partnership. In fact, my institution, Brno University of Technology, is a part of a larger consortium called CETEC, Central European Institute of Technology, based in Brno. And these 6 dots you can see here represent those 6 institutions, either universities or research institutes. So BUT is one of the institutions. Some of them may recognize the symbol or the logo from if you just stopped by the Czech stand yesterday and took some of the small things there. So these are coming from Brno. And as well for University of Agder. In fact, University of Agder has 2 campuses in the very south of Norway. The first one is in a larger city, Kristiansand, and the second one in the small one, Grimstad. And what's interesting about Kristiansand had its own brewery, so some of you may also encounter these yesterday at the Norwegian stand.
Good beer facilitates learning.
To be honest, from those 2 countries, from the partner countries, this is my favorite beer. So that's why I brought it here.
That's by a Czech.
No, it's Norwegian.
Yeah, but this is something that is said by a Czech.
I have a different opinion, so I like Czech beer.
It's a mutual exchange, you see. Especially what we were collaborating with Metric, which is a Center for Research, Innovation and Coordination of Mathematics Teaching. It's one of the 5, I guess, centers of excellence in Norway.
8 now.
8 now.
But they're only in mathematics.
And the only one in mathematics. So this is our particular partner at University of Agder. So what was our original idea was that we as human beings represent a variety of properties and features and so on. We are all different in a lot of ways, but still although we are different, we can have similar problems or issues, and one of them definitely can be with learning mathematics. So this was the starting idea for our project, and here I give floor to my colleague.
Thank you, sir. So, you know, he is young and I'm old enough, I saw dinosaurs, and I still can say things. You remember when I was young, it was like that. So this is exactly this situation. I'll give you just some very brief information about what was happening years back, and then how it was projected on what we have nowadays, and then back, and then we'll make some conclusions of that. So it was an experiment with the Calculus 1 course done by one of the professors at the American University. So his name is Stephen Wilson. And he was given exactly the same exam to students in 2006 in the fall semester as it was given years back in 1898. And I was already, I think, the graduate at that time. So he gave this exam, and then he was checking the result. So the SAT mathematics scores, this is like the requirement to enter American University. You need to pass this SAT with a reasonable score. So they were nearly identical if compared just numerical data and percentages and the population of the class, like art, science, distribution. It was more or less even in both cohorts, 20 years ago and now. And what is happening is that the contents of teaching didn't change much, so it was more or less the same stuff. Then, what we see as results, in 1989, 27% received A, 23 Bs in this course with that exam. And in 2006, when they are graded on the scale of 2006, then we have much better performance. 32% has got A and 37% has got B. So we see like it's quite an interesting improvement. But if we now grade those students on the scale from 1989, then we see that only 6% those current students receive still grade A, and 21 is the drop from 37 for Bs. So what is even more interesting is when they grade the class of 89, then 52% are A's, 26 B's, so we were excellent students when the dinosaurs were around. Now, this is really a serious problem. So something should be done. We know that the level of education should be maintained high. There is more demand for educated graduates. The problems are appearing just like that. So we have students who seem to know more and have better knowledge, but it's not the case. So what he says is that I'm inclined to conclude that the 2006 students are not as well prepared as the corresponding group was in 1989, despite there being significantly more competition to get into this university today than ever before. As it stands, universities have no way of rejecting applicants who do not know arithmetic adequately for college-level mathematics. So there is a high demand for education, there is a high competition, students have low knowledge, the university cannot reject them. We need to do something about this. And I suppose that now we come to this big idea. So the big idea is that one size doesn't fit all. We need to have more individual approach to students. We need to respect their learning attitudes, their personality profile, and take into account many factors. That makes the problem really very complex, but we have some ideas about this. And Josef will be talking about this right now.
Yes, thank you, Yuri. So now, thanks to the support we got from the Norway grant for our project Platsum, we could go on these ideas, with these ideas. So what we implemented in the project was that we designed a questionnaire for the students, then collected some data and did some data analysis, and then we saw what happened. That was the original plan. But of course, sometimes the life is hard and things are not going as we wish. So we encountered several, say, issues, like especially with data collection. Because, say, for example, in the Czech Republic, it was not that difficult to collect some data, or at least some data which can be sufficient for concluding some, coming to some results. But in Norway, it is a serious problem. It was very difficult to collect enough data, and
we are still collecting.
We are still collecting. This is it. So, what can we say about the results we got from the Czech students? It is that basically the analysis said that these data agree with the previous studies done in Norway, because the original idea we already took in Norway, yes, and that some personality types are really disfavored of our ways of teaching, how we teach them, especially people who are, say, in feeling and extroverted groups, coming from these Myers-Briggs test indicators. And it also revealed that certain personality types prefer a certain learning strategy. So I will not comment about it more, but there are some differences between specific groups of personality types. And also, it could be expected that some of the personalities tend to come less to the lectures and exercises and so on. So the question is if indeed we should keep the idea that one size does fit all or not. Yes, so we still believe that we should follow this approach and to study more and learn more about this. So we are now. Thank you very much for your attention.
Congratulations, 2 minutes before, so you can keep on sleeping for 2 more minutes.
You know, people usually come to those events prepared, so they plan well ahead their presentation. We didn't. So I'm very sorry to say that there is something we forgot to tell you. And it's really important. So after having this positive experience with the closing conference in Prague, where we had many people approaching us and asking questions and making suggestions and suggesting partnership. And after overall very nice experience with those Norway grants, we decided to go further. So we have got a very strong team. And this team now comprises of 6 countries, 7 universities. So we have German partners, Spanish partners, England, we have Netherlands, we have 2 universities in Czech Republic, we have Norway, we have a really nice team, and we work really hard. So we work on the proposal right now. Sorry, I said we work hard. So we really are preparing very well for the Erasmus Plus proposal. The deadline is next week. I am coordinating this on behalf of all our partners, and you really see that we invest energy, and this is like the next step, but it's not where we will stop. So we will come back, we'll apply for more grants from this project in the future. We will launch them further, we will grab all the money, because our estimate is like we have great ideas for 73 million. And that's only rough estimate, it's pre-pilot. So we will be knocking on your door and begging for more money, and please support us. Thank you.
Let's start collecting some of those money.
Donations are welcome, credit cards are accepted.
Yeah, I'm pretty sure that probably 3/4 of them will go in order for them to start working even harder with all those beers in front of them. But well, life is tough sometimes. And,
True.
Yeah. Okay, any questions? It's coming again.
I have a very strong concern about. My question is, why you think that extroverts are disfavored in maths? Because, for example, myself, I'm very extroverted. In the high school, in the secondary school, I was very good in maths. I don't want to boast for that, but really, I mean, according to what tests or what criteria did you say, okay, extroverted? Because, for example, I'm doing HR management, and we have a lot of tests using for the personality types. Belbin test, 16 personalities, and so on, so on, so on. And according to which, I don't know, what standpoint you use to say, okay, extroverts are disfavored, or maybe just for the sake of that experiment?
I'll give you an explanation right now. First of all, your glass is empty, so Yossi can help you. And then you will learn better. And second thing, directly to your question. So when we talk about you being disadvantaged, is because you wish to be taught differently. It's not that you are not ready to get this knowledge, but you want to see something different. You don't want to see my back and me writing something on the board and speaking in monotone voice. So you want to see some movie from YouTube which shows where this mathematical idea has been implemented, and then they say, okay, you see it works, and now we'll prove this theorem.
Yeah.
So this is the way we are planning to do the things. It's not that you can't learn, but you can learn much better with more enthusiasm, with better outcomes, if you are fitted a little bit better with your personality profile. But of course, individually, in the very far future, probably you will have just your own package for yourself only. You enter the university, you take tests regularly, you adjust your study program, and then finally you become the absolutely fabulous expert in whatever field you have chosen. But this is very expensive, and now we cannot do it. So this is a kind of pilot which, like a teaser, showing that what could be done, but we are experimenting on a smaller scale.
Yeah, I see. And just the follow-up question, if I can.
He wants more beer.
The follow-up question is, what has higher impact on the learning outcome? The teaching approach or what personality I am? Because my personal opinion is, doesn't matter what we are here, but it matters really what is your teaching approach as a maths teacher.
And your learning strategy, how you yourself engage in learning. If you're a passive listener to me, whatever I do in the class, I cannot directly mechanically transfer my knowledge. You need to be active, you need to respond, you need to be a participant of this dialogue, and when I see your feedback, I can adjust my teaching of you in certain ways so that I meet your demand. But if you're not active, if you're not interested, if you're not engaged, whatever we do, even if I come in a glittery cloth like girls yesterday and sing here about maths, won't help.
Okay, thank you.